Alright, today we're here to talk about ellipses, a second conic section, and I want to talk about the parts of the ellipse. So the ellipse is going to have a semi-major axis, and that is going to be the longer of the two axes, a semi-minor axis, which will be the shorter of the two axes. So if you have a long axis and a short axis, the long axis will always be the semi-major, and the short axis will always be the semi-minor. And the semi-major axis is always denoted by the letter A in our formula. And the semi-minor axis will always be denoted by the letter B in our formula. And the focal axis, or what's called the foci is a set of points that are on the major axis. The focal axis is the distance to the foci, and that focal axis is always going to be denoted by the letter C. Okay? And so I've got a drawing here I want to show you. So the semi-minor axis is here, and it's 4. Okay? The semi-major axis is here, and it's 6. Okay? And the major is always bigger than the minor, so that's why he's the major axis, right? So this would be A equals 6 and B equals 4, okay? And again, just to make sure I write this down so that you know it, A is always greater than B in an ellipse. Always, always, always. And then the third one is the focal axis, okay? This focal axis is denoted by the letter C, and it's always in the direction of the major axis. So in this particular example, the major axis is horizontal. So, the focal axis is also horizontal. All right, so let's talk about the forms an ellipse can take. Okay, normally we put our ellipses in what we call center form. Okay, center form is going to look like this: x minus h quantity squared over a squared, y minus k quantity squared over b squared equals 1. That's a horizontal ellipse. Okay, a horizontal ellipse. Why? Because the major axis, let me write it over here, the major axis is horizontal. Major axis is horizontal. Okay? A vertical ellipse, what do we notice? Here's A, and so the vertical ellipse, the major axis, is vertical. Okay? And what do we know? This is the semi-major, semi-minor, and just like a circle, this is the horizontal translation, and K is the vertical translation. And we'll do some examples with this in just a moment. Hopefully it'll all make sense. Okay? So let's start with, what if we wanted to put an ellipse not in center form, but in expanded form? Okay, so I'm going to show you how to do that. So if you ever see the question, write the equation for this ellipse in expanded form. Let's start by saying this is a horizontal ellipse. Okay, horizontal ellipse. Okay, and we know that because this term is bigger than this term. So the x term is larger. Okay? So here we can say A is 5 and B is 3. And that'll come in handy later, not for this particular example. Okay? A is 5 and B is 3. Okay? So how would we turn this equation for an ellipse in expanded form into an equation, this equation in center form to an equation in standard form? And the answer is, just like a circle, just like anything else, we want x squared plus so many x plus y squared plus so many y's. So the first thing we're going to do is multiply by the LCD. Okay, multiply by the LCD. Now, the least common denominator between 9 and 25, the factors of 25 are 5 and 5. The factors of 9 are 3 and 3. So they don't have any common factors. And so the LCD will actually be 9 times 25. And the fun thing is you don't actually have to know what 9 times 25 is until the very, very end. And I'll show you that. So I'm going to take this original problem here, and I'm going to multiply by 9 times 25. And I'm going to multiply here by 9 and 25. And I'm going to multiply here by 9 and 25. And here, the 25 and the 25 give a quotient of 1. And so I just end up with 9x minus 2 squared. So 9x minus 2 squared. Plus, and here the same thing happens with the 9's. And so I end up with 25y plus 3 quantity squared. And that's equal to 9 times 25. Okay? Well, 9 times 25 is 225. Okay, so we'll jot that down. All right, so now I need to expand this and multiply by 9. And be careful. I'm going to come over in a different color here and just write this real quick because it's really important that you know this. X minus 2 squared is not x squared minus 4 or x squared plus 4. That's a very, very common mistake that people try to distribute a square. That is not possible, okay? Instead, what we have to do is say x minus 2 times x minus 2, okay? And that's going to give me x squared minus 4x plus 4. And similarly here, this is going to give me 25 times y squared plus 6y plus 9, okay? Now, we're going to distribute this 9. Okay, so distribute this 9 and distribute this 25 and see what that gives us. Okay? So here I get 9x squared minus 36x plus 36 plus 25y squared plus 150y, okay, plus 225 equals 225, okay? And this is going to be that 25 times y squared, 25 times 6y, and 25 times 9. And then magically these two are going to go away because if you subtract 225 from either side, you get a 0 quantity there. So what's left? Let's put this in standard form. So, or expanded form. It's going to be 9x squared minus 36x plus 25y squared plus 150y. And then the 36 will go on the end. Plus 36 is equal to 0. Okay? And that is what's considered expanded form for an ellipse. Okay? So to write the equation of an ellipse in expanded form, we simply multiply by the LCD and then distribute the term that we get out front. And that's it. So if you're ever asked to put an equation of an ellipse in expanded form, it's pretty simple. Multiply by the LCD and then expand the binomial, so the x minus 2 or the y plus 3, whatever quantity you get there, and then combine all your like terms, okay? So a second thing I wanted to do here is if you were given a graph to write the equation, okay? So we're given an equation, we're given a graph, and we've been asked to write this equation, okay? And so to write this equation, the first thing we have to do is find the center, okay? And if I look, I kind of can see that this ellipse goes there and there, and a lot of times they'll give you the center, okay? But in this case they didn't, but there's the center, okay? The center is at 1, 1, Okay, 1, 1. And then I look and I say, okay, this axis here, 1, 2, 3, 4. So this is 4. And this axis here is 1, 2. So this is 2. The larger number is going to be A. The smaller number is going to be B. Okay? So A is 4, B is 2. Now as a reminder, we want our equation to look like this. Okay? So these have to be A squared and B squared. And then these here tell us where this has been moved. Okay? Well, where has it been moved? If this thing would normally be at the origin, it's been moved to the right 1. So I'm going to write that down. To the right 1 and up 1. What's that going to look like in the equation? What's that going to look like in the equation? And so the equation is going to look something like this. I'll actually put it over here. So it's going to be x squared over a squared. So that'll be 16 plus y squared over b squared, which will be 4, is equal to 1. Okay? And then this right 1 is going to be minus 1, because if you recall from algebra, anytime something is grouped with a term, it's always going to do the opposite of what you would think. So to the right 1 will be minus 1 here. And the same thing with y. Up 1, because this is going to be grouped with y, is going to be minus 1. Okay? And there is your ellipse in center form. Okay? What if they wanted this same formula in standard form? Okay? What if they wanted the same ellipse formula but in standard form? Okay, so I want to work on how to get that as well. Okay, so there's center form. If we want to get this in standard form, right, which is what I'm asking for in this question here, I'm asking for the equation, the equation of the ellipse in standard form. Okay, so what are we going to do? Well, we've got to find the LCD first. LCD. Well, 16 and 4 actually have 4 in common. And so the LCD for this is going to be 16. So how do I get this in standard form? I'm going to multiply, or expanded form. Some people call it expanded form. Multiply everything by 16. Okay? Well, these go away. This 16 breaks into 4 and 4, and one of the 4's will go away. And so we're going to end up with something that looks like this. We're going to end up with x minus 1 squared plus 4 y minus 1 squared equals 16. Okay? Square that, you get x squared minus 2x plus 1. You square that, and you get y squared minus 2y plus 1. Okay? Now, you just want to start, you're going to distribute this and then combine your like terms. So you get x squared minus 2x plus 4y squared minus 8y. And then this guy, and 4 times 1 is 4. So it'll be plus 1 plus 4 minus 16 equals 0. Okay? So this guy, this 1 goes here. Okay? This 1 is going to be multiplied by 4. It went here. And then this 16 is going to be subtracted. Combine those like terms, and our final answer will be x squared minus 2x plus 4y squared minus 8y. Right? And 1 plus 4 is 5. And 5 minus 16 will be something like negative 11. And that will be our equation in standard, right? Standard or expanded form. Okay, standard or expanded form. Okay, so standard or expanded form, center form, and then the actual graph, and how these three relate to each other. Okay, so if you have any questions about ellipses, let me know, and I'll have another video coming up shortly.